Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh again. And today is the 27th of April, and we are going to understand, we are going to look at chapter 5. Okay, so basically, what does chapter 5 tell us? Okay, so chapter 5 is looking at CPU scheduling. Okay, so what does that mean? It means that how the operating system manages or controls each process to be brought into the CPU to be processed. Okay, so there is a certain type of schedule that the operating system must do in order to make the CPU utilization at the most effective level. Okay, why is that so? Because the CPU can only process one process per time. Okay, if the process that comes into the CPU or into the processor is not controlled, meaning that means other processes cannot come in, because each process only is taken out once the process has finished. Okay, so the CPU scheduler will make sure that each of the process inside the RAM has an equal chance of being processed. So what are we going to understand today, or maybe in the whole of chapter 5, is the scheduling criteria, algorithm, multiple processing schedule, and real-time CPU scheduling. Okay, so this first one, criteria and a bit of algorithm, is basically on theory side, but we are also going to do some calculation. But here, multiple processor scheduling is fully on calculation. All right, so CPU scheduling is the basis for multi-program operating system. What does multi-program mean? Multi-program means the operating system can run multiple programs at one given time. Okay, to describe various CPU scheduling, so we are going to understand and we are going to look at various scheduling methods which are available and examine each of them and to see which is the best algorithm. Okay, so the basic concept is, before we continue, is you must understand what is the CPU bus followed by the input-output bus. Okay, before we understand. CPU bus is when the process is being executed in the CPU. Okay, so that's quite simple. Okay, when the process is being executed inside the CPU, this is called CPU bus. That means the CPU is doing something. However, an I/O bus stands for is when the CPU, is when the CPU is waiting for an input-output for further execution. Okay, what does that mean? Meaning the process cannot continue or cannot even start until an input or output is available for it to be utilized. Example, for example, if you go to the hypermarket kat Tesco or Maiden or Aeon, at the counter, when the cashier wants to scan each item, the system which is in the cashier machine, or the system which is in the counter, is waiting for an input to come in. Why do I say that? Because each time you pass through, and each time the cashier scans an item, automatically it's being processed. It is not that she or he, the cashier, needs to on a particular machine and then only it utilizes. The process is already waiting for some instruction. Okay, so that is an example of a I/O bus. That means it's waiting for something to happen. It's waiting for an input or an output to happen. Only then it can go for execution. What kind of execution is that in the cashier? Well, the price is being displayed, so that's a execution. Okay, so the CPU bus is when the processor is inside the inside the CPU, and the I/O bus can be inside the RAM. Okay, it's inside the RAM and it's waiting for something to happen. So each process needs to be scheduled well. Either it's CPU or IO. Because just imagine if the process is inside the processor being processed, tiba-tiba it needs an input from something else. So it's just waiting there. It has not completed, but it cannot, and other processors cannot enter the CPU because there is no input for the first process. So the process will be inside the CPU waiting for an input to happen. All right. So that's why the process needs to be scheduled between a CPU I bus and an input output bus, between both. Okay. It has to go back and forth, back and forth. Or else, let's say the process is waiting for input and there is no going back and forth, then the process will just hang like that because it's waiting for something to happen and that thing has not happened. Yeah. Okay. So there is a scheduler kat sini. Ada scheduler. What is the job of scheduler? The scheduler is a sort of software inside the operating system that brings the processes from the memory, okay, from the waiting state back into the running, or from the running state back into waiting state. That means from the CPU back to the memory, and from the memory back into the CPU. That is a scheduler. However, the term short-term scheduler, okay, short-term scheduler is different. There are two types of scheduler you need to know. I think you can refer this to chapter 3. Long-term scheduler and short-term scheduler. Please read on this. What is the difference between short-term scheduler and long-term scheduler? In short-term scheduler, you can see here, among the processes inside the ready queue, and allocate CPU to one of them. So where is the ready queue? Ready queue is inside the memory. So the scheduler will take the process daripada memory, masukkan dalam CPU. That's how it goes. Okay? And scheduler punya job. What is the scheduler's job? Or what is once the process is inside the CPU, what does it do? Okay? So there are certain algorithms that bring out the process. Okay? We can call it the non-preemptive. Is allocated to the process until it terminates, meaning there is an algorithm by the operating system. If the process is inside the CPU and is being run, let it run until it finishes. If it takes about 5 minutes, go ahead. It's called the non-preemptive scheduling algorithm. As compared to preemptive, what does preemptive mean? Preemptive means if the process is inside the CPU and it has not completed, and there is a new process coming in, the new process gets to go in first. Okay, so the preemptive is normally used in when there is a time for each process. Let's say each time for the process is only 6 seconds. So after 6 seconds, the process comes out of CPU, back to ready, back to the memory, and a new process comes in. That's called the preemptive. The non-preemptive is, let's say the process needs to run for 10 seconds, so the process will run for 10 seconds. Even if there is a new process waiting inside the memory, the process will have to wait until the old process completes its entire process. That is what we say as the non-preemptive. Okay, so what is a dispatcher? A dispatcher is a different type of software under the operating system. Okay, the dispatch gives control, that meaning to say the dispatcher brings the processes from the memory back to the CPU. It's almost the same as the short-term scheduler as well. Okay, and then we have the term called dispatch latency. Time it takes for the dispatcher to stop one process and start another one. Okay, so the short-term scheduler is merely to bring the process from processor, from CPU back to memory. Itu kerja dia. The short-term scheduler is just to bring. But to start the process is what we need the dispatcher for. The dispatcher is to start the process. So the latency here, the time it takes for the dispatcher to stop one process and start another process. Okay, what do I mean by this? Let's say process number 1 is running inside the CPU. and it has been running for 6 seconds. It has, okay, although it needs to run another 10 more seconds, but the time given for process number 1 is only 6 seconds. So process number 1 will be carried out back to the, by the short-term scheduler back to the memory. So the dispatch latency means the time for it to stop the process, okay, and then the CPU scheduler takes in, okay, the short-term scheduler takes in, put it back in the memory, and restart a new process. So that's where the dispatch latency begins. That is calculated. Okay. So how do we choose, or how does the operating system choose what process to bring up, or how to do this? It has a few criteria. It has to look at CPU utilization, throughput, the number of processes that can complete the execution per time unit, turnaround time. Okay, turnaround time is the amount of time to execute a particular process. What is the total turnaround time? What is the waiting time? How long does the process have to wait? Okay, and the response time. Okay, the throughput means the number of processes. Let's say you have about 6 processes inside the memory. Okay, so what is the throughput? How long does how many processes can be completed in 10 seconds? Okay, so we are looking at this. All right. So the first algorithm method that we are going to learn today is what we say is the first come, first serve, the most easiest one. Okay, so the most easiest one is first come, first serve. Okay, so first come, first serve means the first process that comes into the memory is run first. Okay, the first process that comes into the memory, the first process that comes into the memory is being run first. So the bus time here, meaning how long does the process needs to be processed. Okay, so this is how we calculate or do it. All right, so let's say process 1, 2, 3 both sampai at the all three comes to the memory at the same time. Okay, so at the same time, P1, P2, and P3 come inside the memory, right? And 2433 is the number of the time it needs for it to process inside the CPU. Okay, so P1 needs about 24 seconds to be processed inside the CPU. P2 needs about 3 seconds to be processed inside the CPU. And P3 also needs 3 seconds to be processed inside the CPU. So this is how we draw. So all the process comes at time 0. So P1 is until 24, continued by another 3 seconds for P2 and P3. Okay, so how does this algorithm work? This algorithm works by which first come, first serve. The first process inside the memory is being processed first. All right. So what is the waiting time? What is the waiting time? How long did the process wait for it to go in? Assuming all of this process came at the same time. Tapi masuk lambat. Example, process 1, 2, 3 came at time 0. The first process we went in is P1. So P1 waiting time is 0 because when it came in at 0, terus masuk for 24 seconds. P2 came in at 0. Betul, it came in at 0, but it only got in at time 24. It only got in. It only being processed at 24 seconds later. All right, for 3. Okay, so you can see here, 24 plus 3 is P2. All right, next P3 arrived at time 0, but it only got it at time 27. So here, so this is the waiting time. So average waiting time is 0 plus 24 plus 27 divided by the number of processes that you get, 17. So the average waiting time for each process is about 17 seconds. Any questions so far? Do you understand this first algorithm, this first scheduling method? Okay. Okay. So this is how. Now, Let's say we have another example here. Almost the same thing, but in reverse order. Okay? Assuming P2, PU3, and P1 arrive at the same time, which is time 0. Okay? So P2, P3, and P1 arrive at the same time. So obviously, bila in this order lah. Okay? Obviously, in this case, P2 will go in first, and then followed by P3, and then by P1. Okay? As you can see here, the waiting time changes as compared to the previous one. The waiting time for P1 is now 6 seconds because it came at 0, it only entered the CPU at time 6. P2 is 0 because it came in at 0, masuk pun terus 0. And P3 is what we say as came in at 0 but went in at 3. So the average waiting time is 6 plus 0 plus 3 divided by the number of process, so you get 3. This is way much better than the previous example. The previous example said the average is 17 seconds. Whereby, in this case, it's only 3 seconds. That means each process just waits for 3 seconds and then you can go in. Okay? So this is what we say is the convoy effect. Short process behind the long process. Okay? So the operating system will decide because it will scan through the memory and see which is the shortest process and which is the longer process. How do you define short and long process? Simple. You define it through the time it needs to process. Okay, although it comes all at the same time, the algorithm, but the operating system will choose the best possible method for the process to be executed by the CPU. All right, next method, which is quite simple as well, we are using the shortest job first, meaning assuming at time 0, all the process comes in, so the the OS will select the shortest process gets to run first. Okay, the shortest process gets to run first. That is how we do it. Okay, example kat sini. Okay, so we have 4 processes here, P1, P2, P3, and P4. Assuming all arrive at the same time, which is arrive at time 0. So P4, kenapa kita masukkan P4? Because we are looking at the shortest job first. So we have to compare all this. Among this, which is the shortest job is P4. So P4 goes in. Next, and it completes until the end. Bukan habis-habis halfway ke apa tak. Complete until habis. Alright. Next, at time number 3, P1 goes in. And then P3 and then P2. Okay. So in shortest job first, the operating system looks for the shortest job that needs to be processed. So we start from that and go on. Okay, I always get this question as well. Students ask me, so does that mean each time the operating system will decide first come first serve ke, shortest job ke? Yes, it will decide the best possible way to run that particular process. So you can switch from one to another. Okay, so it does not matter, it does not mean that if it's running on shortest job first, sampai bila-bila dia run shortest job. No, it keeps changing accordingly. Okay, so remember, first come first serve yang tadi tu, the first process yang sampai masuk dulu. Shortest job first, okay, the shortest job that comes in runs first. But in both example, always remember, okay, both examples, process came at the same time. Maksud dia, pada saat dan ketika 0, only then all this process came in. Then you can compare lah, which is the shortest job, which is the first come first serve. Let's think of another example. Let's assume that each process comes at a different time. So dia time 0, process 1. Okay? And then tiba-tiba in masa time 5, process 2. And then time 10, process 3. And then time 15, process number 4. So when you have a different timing, then you have to look again as well. It's a different method as well. But it's easier if the processes arrive at the same time. Okay? Now, This is another concept. Shortest remaining time first. What does that mean? This means if the arrival time itu berbeza, plus we are using the shortest job first method, okay, which is called the shortest remaining time. What does shortest remaining time mean? Shortest remaining time means, let's assume that the burst time, the process needed, the burst time for a particular process is 8 seconds, okay, 8 seconds. And dia dah masuk dalam CPU, dah masuk dalam schedule, dia dah run those dia dah run 3 seconds. So baki lagi 5 second, right? So baki 5 second is what we say is the shortest remaining time. Okay, so the remaining time for that particular process is 5. Okay, so let's look at this example. Now, if you look at this example, the arrival time tu sudah berbeza. That means each process arrives at a different time. Time 0, time 1, time 2, time 3. And the burst time also changes. Okay, let's look at this one. P1 arrives at time 0. Okay, arrives at time 0. At time 0, there is no other process arriving at the same time. Because P2 arrives at the next second. P3, lagi 2 saat. P4, another 3 seconds. Okay, so at time 0, there is only one process. So P1 can run first. Okay, P1. Okay, so bila sampai kat time 1, dia stop. OS is going to check dengan memory. Ada tak proses lain sampai? Oh yes, ada. P2, sorry, at time number 1. Okay, time number 1. Okay, so now OS will compare. The burst time needed for P2 is 4. P1 dah complete 1, so baki yang belum complete is about 7. So between 7 and 4, which is the shortest? Okay, which is the shortest? The shortest is 4. So P2 akan buat 4. Okay, so dia buatlah 1, this is 2, 3, so this is 2, this is 3, and this is 4. Okay, so dia dah buat 1. Okay, bila dekat 1, dia stop for a while. Stop, tengok. Is there any process here which arrives at time 2? Yes, process 3. But the burst time is big. Okay, P2 punya burst time is smaller. So dalam algorithm ini, we choose the smaller burst time. Okay, so it continues until P3, until 3. Okay, at time 3, dia tengok balik. Is there any other process? Yes. P4, but it's 5. Okay, it's small, it's bigger than P2. Alright, so P1, dia akan continue until 5 seconds. Because burst time dia 4. So 1 campur 4 is 5. Alright, next, there is no other process coming in. So P2 is completed. Now tinggal P3, P5 and P1 dengan baki dia 7. Okay, so between 5, 9 and 7, which is the shortest? The shortest is P4. So P4 buatlah sampai habis. And then P1, because that's the next shortest. And last but not least, P3. Okay, habis kat situ. Alright, so this is what we say as the shortest remaining time. So now and the shortest remaining time is what we say is preemptive. Kalau you masih ingat in the first few slides tadi, preemptive means the process can be taken out and put it back. Taken out, put it back. Okay, so the average waiting time untuk setiap proses ialah berapa? Okay, what is the average waiting time for each process? Okay, so we have to do it one by one. Okay, so this one is P1. Kat sini. This block here and this one here. Dalam block ini, how long did P1 wait? Dalam block ini, P1 has waited. Kita tengok balik. Arrive 0, baru masuk 10. Okay. Tapi before that, you tengok, dia dah masuk kat sini dah. So in this block here, the waiting time is nothing. 0 lah. Sebab sampai 0, masuk 0. So the waiting time is 0 here. Which is this one. habis dekat 1. Another time P1 masuk ialah 9 seconds later. So tadi dia habis dekat 1. And then dia restart balik at 10. So 9 seconds later. So that's why P1, that is why 10 minus 1. Next, we look at 17. We look at what is P2? All right. Next, why is this? Sorry. 5 minus 3. Oh, yeah. Okay. Right. Okay. Next, we look at P3. P3 masuk only at 17. But dia dah sampai at 2. So, how long did it wait? 17 minus 2. Alright. Next, we look at P4. P4 masuk at 5. But it has come at 3. So 5 minus 3 is 2. Divide by the number of process and you get this as your average waiting time. Okay, average waiting time. Next, we look at priority scheduling. That means each process is given a priority. Ada satu elemen tambahan, which is priority. Yang tadi tu, we are talking at first come first serve. Proses pertama sampai, proses pertama yang masuk. Shortest job first, that means the process which has the shortest job in overall. Shortest remaining time, dia dah buat, what is the balance? So we are looking at the balance. In this location, in this example, in this slide pula, we are looking at priority. Meaning each process is already given a priority. Okay? So, but the only problem is you have problems like starvation. Let's say there are about 5 process. Kalau satu proses tu diberi low priority, so sampai bila-bila dia starve kat situ. That means starvation means dia tak boleh masuk CPU. Okay, let's say now is the turn of a new process nak masuk CPU. Tiba-tiba ada CPU lain, new process masuk, then dia akan conflict, dia akan tengok priority, and then the higher priority, the better. Okay, alright. So let's look at priority. Again, we have the same thing. We have the process here, we have the bus time here, but we have a new column called priority. And in this example, arrival time is 0, so it's much more easier. So between all of these processes which came in at the same time, priority number 1 is on P2. So P2 jalan dulu. Priority number 2 is on P5. Priority number 3 is on P1. Priority number 4 is on P3. And priority number 5 is on... priority number 1 is on P2. Priority number... Okay, the next priority is on P5 because number 2 kat sini. And then the next one is on P1 because this is 3. And then the next one is priority 4, process number P3. And then finally is on P4. Okay. So this is how we do it. And this is how we're going to calculate the average waiting time. P1, P2 average dia kosong sebab dia sampai kosong, dia masuk kosong. P5 dia sampai kosong, dia masuk at 1. Okay. P1 dia sampai at kosong, dia masuk at 6. P3 dia sampai at 0, dia masuk at 16. And P4 dia sampai at 0, dia masuk at 18. Okay, 18. So plus all divide by the number of process, then you can get the average waiting time for priority scheduling. Okay, so this is an example, another example on priority scheduling as well. Okay, so we stop here. Sorry, is there any questions? Right. All right. So we stop here today. On the next one, we will continue on round robin. Okay, stop here. And the next class we will do on round robin. So what we have done in this lecture is we have understood what is first come first serve, what is shortest job first, shortest remaining time first, and also priority scheduling. Okay, time is priority scheduling. So I hope in the next class we are able to do the round robin plan. Okay. Hope you understand, and inshallah I'll see you in the next